Before we go deeper, this is the architecture we're going to break down. Start from the left. A customer places an order through the front end. The request reaches our backend, and the order is stored in the orders database, our source of truth. From there, we move into an event-driven model. EventBridge helps us decouple the downstream work, inventory updates, invoice processing, and customer notifications. And separately, we have an analytics path using Kinesis and Glue, with processed data eventually going into S3 and Redshift. So as we go through this, look at the flow from the left. The customer creates an order through the front end, and that request comes into our backend API. The backend has one critical responsibility shown underneath it: save the order into the orders database. But look at everything else the backend might also need to do. Update inventory, create an invoice, send the customer a confirmation, record analytics. If the backend calls all of these directly, checkout now depends on all of them. A slow invoice service can affect the customer. A notification failure can cascade back into the order flow. And each component becomes harder to scale independent. Again, start from the left. The customer sends the order through the front end to our backend API. Now look underneath the backend. Before we fan anything out, we persist that order into Amazon RDS. That is important because the database is our source of truth. Once the order has been successfully created, the backend publishes an order-created event into EventBridge. And you can see an example of that event at the top: order ID, customer ID, amount, and timestamp. One important production point: EventBridge is not processing the order. It is routing the event. And because database persistence and event publication are two separate actions, this is also where I would consider an outbox pattern or controlled retry mechanism. Once EventBridge has that event, this is where the architecture starts to fan out. On the left, our application publishes the event into EventBridge. EventBridge now routes that same business event to different consumers based on rules. Take the first branch. Inventory needs a fast update, so we can invoke Lambda and update the inventory database in DynamoDB. The second branch is different. Invoice processing might take longer, so instead of tightly coupling it, we place the work into SQS. The Lambda invoice processor can then consume those messages at its own rate. That is the key distinction on this image. EventBridge routes, SQS buffers work. The third branch handles customer communication through SNS and SES. And at the bottom, we can optionally archive events so they can be audited or replayed. At the top, we have a condensed view of the operational side we just discussed. The customer creates the order. The backend stores it in the orders database, and operational workloads such as inventory, invoicing, and notifications continue independently. Now look at the separate path along the bottom. The backend also publishes transaction data into Amazon Kinesis data streams. Glue continuously reads that streaming data. Then we use Glue with Spark or PySpark to clean, enrich, and transform the records. From there, the results can go into Amazon S3 for the data lake or into Redshift for analytics and reporting. And that's the important architectural separation on this image. Operational processing answers. First, look at the center. We now have our complete design: customer, front-end, back-end, database, EventBridge, asynchronous consumers, and the analytics pipeline underneath. But as a lead architect, drawing the architecture is only the beginning. I start on the left with bottlenecks. Can the backend handle the traffic? What happens to database connections and IOPS? Is the SQS queue growing faster than we process it? And can Kinesis handle the required stream throughput? Then I look at cost, Lambda duration and concurrency, SQS requests, Kinesis capacity and retention, Glue compute, and Redshift all need to be justified. Now move to the right. For reliability, I want idempotency, controlled retries, dead letter queues, replay capability, monitoring and alerting, and finally, security, least privilege IAM,